Today we have an Aetna, A-E-T-N-A, tube radio from about 1935, and according to my research, that was a Walgreens house brand. Yes, Walgreens Drugs had their own line of radios during the 1930s, mainly cheaper sets, and this is one such set. Just a little standard broadcast AM only radio. Now let's open it up and see what we've got inside. Okay, here's the chassis removed from the cabinet. This is a 4-tube TRF set of the AC-DC variety, no power transformer. We have our output transformer for the speaker here, and this other deal right behind here is a filter choke. We still have our original cloth-covered power cord that will be replaced. Here's the underside of the chassis. Looks basically untouched. These little cheap radios were fairly common during the Great Depression for obvious reasons. They were cheap, but they're not as common today because most people didn't bother having them repaired after they stopped playing. You know, if they got 5 or 10 years out of one, and if something other than a tube went bad, they usually just tossed them and threw them in the garbage. Now that brings us to something very interesting here that we need to try to figure out what it is. This power cord actually has 3 wires coming out of it. So does that mean this is an early form of a grounded power cord? Well, let's see. No, that's not what it means, since we only have a 2-prong power plug. Okay, does that 3rd wire mean some kind of an antenna lead built into the power cord like on the Motorola wireless record players? Well, no, that's not what it means either. Okay, well, I will now show you what it means. Okay, up until this point, we've repaired several AC/DC style radios since I've been posting YouTube videos, but mainly what we've been repairing has been post-World War II stuff. And in these sets, obviously we have 5 tubes, a 12 SA7, 12 SK7, 12 SQ7, 50 L6, and 35 Z5. And the number prefix of each tube indicates the filament voltage, so adding that series string of voltages together gives us 121 volts. Well, that's perfect for the AC line input that can range anywhere from 110 to, say, 125 volts. That's perfect. However, before World War II, the higher voltage filament tubes were not very common, and depending on how far back you go, in some cases had not even been developed yet. And as you can see, I still haven't replaced my printer cartridge yet. So that means this schematic diagram will have to be put under my enlarger. That might help a little bit. Or else I just need to go get off of my wallet and go buy a new ink cartridge. But anyway, the 4 tubes used in this set are types 25Z5, which uses a 25 volt heater, a type 43, which uses a 25 volt heater, and a type 6C6 and a 6D6, which both use 6 volt heaters. Well, when we add this series string together, that gives us 62 volts, which if we apply 120 volts AC across that string, we will burn the tube filaments out in short order. So how do we get around this problem? Well, we have to add some type of power resistor in series with the tube heater string, or filament string, whatever term you choose to use, in order to drop that excess voltage, because 62 volts is roughly half of the incoming 120 volts AC, give or take. And manufacturers generally had 3 ways of doing this. Number 1, they used a device called a ballast tube. Now this ballast tube looks much like an ordinary vacuum tube and plugs into a socket on top of the radio chassis. However, this tube contains an internal resistance element, and this tube also gets very, very hot. The second way of doing it, which was used on some of the better radios, was to mount a high-powered can-ohm type resistor to the chassis. But there again, this type of resistor gets very hot and may not be suitable in some sets that use a smaller chassis, such as this one. The third way of doing it, which is the most common way on cheaper radios, is to have the resistance element built inside of the power cord. Now, back in the day, they referred to these types of power cords as cord ohms, because they had the resistance element wound inside of the power cord. And yes, these cords did get rather warm to sometimes hot. In fact, they were nicknamed curtain burner cords for that reason. Now, these cords are generally unsafe today and haven't been manufactured in probably 50 years or more, so what we have to do is come up with some type of ingenious solution that won't be harmful to the radio or the radio surroundings. Okay, method number one is to simply install a power resistor in place of the original line cord resistor, but like we've already discussed, power resistors get very hot, and there's often not a suitable place to mount one in the chassis. Well, in years past, I've been using the traditional white ceramic case type power resistors that are available from the local parts house that give off a lot of heat, and it's really not very convenient to mount those types of resistors. Well, I discovered that this wonderful mail-order electronics outfit known as Mauser Electronics, that I've been ordering a lot of capacitors and such from over the years, has these types of power resistors. Now, these are both 50-watt resistors, which we won't even need any more than half of that wattage for this radio application, but better to be safe than sorry. These are encased in metal and are chassis mountable. Now, I'll admit this is the first time I've ever used these types of resistors, so we'll just have to do some experimenting with them to see how hot they get. If the temperature level is okay, then I can probably just mount one of these right here, because there's plenty enough room in this area of the chassis to do that. Okay, well, let's say if the resistor trick doesn't work, here's another trick that we can use. We can substitute this line cord resistor with a capacitor. Now, I won't get all technical I'll just post some links in the description so you can read up on how to calculate what value of capacitor that you need for whatever your application is. The formulas are sort of complex, and complex formulas are something that I'm not very good with. In fact, when I took electronics at the local community college, AC circuits was probably my worst course, where we had to deal with all those formulas. I think I actually only made a C in that course. Everything else I made A's and B's in. All I'll say about the capacitor is you don't want to use an electrolytic. You want to use a non-polarized film capacitor. It'll be somewhere in the area of 8 to 10 microfarads at 250 volts AC. Yeah, you want to use one suitable for AC. And there again, these are small enough now that they can be mounted under the chassis. The third trick is to use a diode, and I'll explain more about that in just a second while I go clean the camera out. Now that we have the camera cleaned out and recharged, get back to the discussion of these diodes. Some people have used a 1N4007 diode in place of the resistor, and the theory is that it cuts the line voltage in half, which leaves you about 60 volts for the tube filaments. Well, Really, there's a little bit more to it than that. You've got peak-to-peak voltage to deal with here, and you know, when the diode cuts off one of the peaks, well, the remaining peak, as seen by the tube filaments, could still be too high and eventually cause tube burnout. And another issue I have with using diodes in a situation like this is diodes can short. Now, someone on one of the forums told me that I was overreacting a bit on that, and if I felt uncomfortable I could wire two diodes in series, which is very true, but in the 25 years of doing this, you wouldn't believe the amount of equipment I've seen that had shorted diodes, mainly due to power surges and lightning strikes, but it does happen. So if I were to use a diode in this filament line and the diode shorted, then we'd be placing 120 volts across a filament line that only wants to see like 62 volts. So the diode will probably be my last resort. I'll probably try it in this experiment just to see what happens, but that will probably be my last resort. And one other interesting thing, the schematic I pulled on this radio before I actually received it was the ultra cheap undeluxe version without a dial light. Well, it turns out this is the ultra cheap deluxe version of the radio with a dial light. And here is the filament string. You gotta love my lovely artwork. Have our 175 ohm quart ohm resistor. Have our 25Z6, our 25Z5 rather. And then we have our two dial lights wired in series, placed in parallel with a 60 ohm resistor. And then we go on through the rest of the tubes. And you might be asking why the resistor here across the dial lights. Well, simple. A series circuit must have equal current draw from all branches. For example, we can't have one branch drawing 300 milliamperes and another branch drawing 150 milliamperes or whatever. Each branch has to be 300 milliamperes. So the way they get around that is more mathematical formulas to figure it out, but they shunt the dial bulbs with a resistor. So this particular branch here will have equal current draw to these other branches here. And another purpose for the resistor is in case one of the dial bulbs burns out, you won't lose radio operation. Let's just say these dial bulbs were 300 milliampere and didn't need the resistor and were just wired in series with the other tube filaments. And if one of the dial bulb filaments was to open, which is very common, the dial bulb's a lot more likely to burn out than one of the tubes. So if that happened, you'd just lose radio operation completely. You'd have a dead set because your filament circuit would be broken. Okay, with all that mumbo-jumbo said, I'll give you some links in the description of this video so you can read all the technical stuff. Like I said, I'm not going to bore you with all that, and I wasn't that good with all the mathematical formulas anyway whenever I was taking electronics. About the only thing that saved my butt was that our instructor would allow us to use the formula sheet when taking a test. It's just he wouldn't tell you which formula applied to what situation. You had to figure that out on your own. But anyway, the person I got this radio from said they'd plugged it in and it's totally dead. So, you know, you're not supposed to do that, but some people haven't figured that out yet. So now let's just do some experimentation with this filament circuit and see if we can obtain the desired results. And reading across the power plug with the switch turned on, I'm getting absolutely nothing, which means the quart ohm is open, a tube filament's open, the power switch could be open, or the dial bulbs could be burned out along with this can ohm resistor here being open. I believe that's the resistor that's actually wired across the dial bulbs. A few ohm meter checks should determine what the fault is. Yeah, here's the problem. No surprise, the resistance portion of this line cord is open. Here's our built-in power resistor here. This whole thing just runs the entire length of the power cord and connects at the other end, connects to the power plug. Okay, I've now replaced the power cord, and since this is a hot chassis set, meaning one side of the AC line connected directly to the chassis, I used a polarized power cord with the neutral side of the line, wide blade, connected to the chassis, and I have the hot side, narrow blade, going through the power switch. Previously, we used a non-polarized cord, and the power switch was wired in the neutral side of the line. Now, this way, no matter whether the radio is turned on or off, and assuming it's plugged into a correctly wired outlet, the chassis will still be safe. And I have our 200 ohm resistor clipped across where the original quart ohm resistor would have gone. And we now have continuity, 279 ohms. That sounds about right. So we'll now plug it in and see how our filament string likes this arrangement. We have our 200 ohm resistor across the line. I'm measuring the AC voltage across the filament string, about 64 volts, which is about within tolerance. And on all original capacitors, I'm getting some garbled reception. Of course, it's obvious the filter capacitors are shot. One of them, you can see it's blown its insides out a little bit. So at least with getting hum and garbled reception, that tells us that all the major organs are good. Now, with this being a cheapy TRF set, I don't expect good performance out of it. In fact, with a long wire antenna, you'll probably be able to get just the local stations on something like this. And also your selectivity won't be that great, which means if you've got a couple of stronger stations anywhere close to each other, they'll probably, shall we say, bleed on top of each other, as in you'll be able to tune from one station directly to another one. And if there's any weak stations in between those two strong stations, you can probably forget it. Okay, this resistor is running uncomfortably warm to the touch, which really doesn't surprise me. Now let's clip our 10 microfarad 250 volt non-polarized capacitor in there and see what happens. Okay, with our capacitor connected in place of the resistor, we're getting about 86 volts, about 20 volts higher than we should be getting. So we need to substitute a different value of capacitor. Okay, with a diode, we're reading about 68 volts across the tube string, which is acceptable. However, I can tell that our filaments are glowing brighter now. And I believe my theory is correct on this. The reason for that is because this meter, it's not reading the peak-to-peak value, it's just reading RMS. In fact, I don't believe there are too many meters that will measure peak-to-peak, but the tube filaments are seeing the peaks here, and that's the reason they're glowing brighter. So probably the best thing to do here is either find a... Okay, what was I saying about the diode before the camera ran out of memory? Well, just suffice it to say, I'm really not a big fan of the diode method for the reasons I mentioned earlier. The diode could short and place full 120 volts across the tube string, and the tube filaments would go bye-bye. In order for me to get the proper voltage with a capacitor, I'm going to have to go lower than 10 microfarads, say maybe 8 microfarad or 6.8 microfarads, something in that range. But these AC rated film capacitors are kind of hard to find in certain values, and You know, I could probably get something, but I'd have to order some parts, and they're kind of expensive, so I think what I'm going to do is, for right now, we're going to go with this resistor in circuit, and I'm going to fix the rest of the radio's problems with this resistor clipped in, and then I'll make an executive decision as far as what device I'm going to use to make the filaments happy. So obviously, since we have that power supply hum, the first order of business is to get rid of these two cardboard filter capacitors that are obviously dried up and not working, and then we'll just troubleshoot it from there. Okay, we're getting there. I've replaced all of the electrolytic capacitors. You can see we've gained a lot more room under here. Here's the AC line across the line capacitor. Here's our tone capacitor that connects from the plate of the output tube to ground. That came loose whenever I unsoldered one end of the line bypass capacitor, so I just went ahead and changed it. The only thing left is the coupling capacitor from the detector stage to the final audio stage, and this bypass capacitor that goes from the plate of the detector tube to ground. I believe its purpose is to filter any unwanted RF from the plate of the detector tube to ground so it doesn't get passed to the audio output stage. Okay, let's plug it up and check our progress so far.
Victory Grill is joining us on the stage, head coach of the Crimson Tide.
It's amazing what a few capacitors can do to a radio.
Victory by your football team over Mississippi State last Saturday. Well, it was a tough game, and our players did a great job.
Okay, I'm checking the control grid voltage of the output tube. I'm getting 16.7 volts on it,
All those guys are really, really good
which we should not get a positive voltage of that magnitude. It should actually be getting a negative voltage, which indicates that either the output tube is gassy or the coupling capacitor is leaky, and I'm voting on the latter. In fact, I'm surprised it's working as well as it is with that much positive voltage there. And on the plate of the detector tube, we're getting about 34 volts. Now, it'll be interesting to see if, after I replace that plate bypass capacitor, if the voltage goes up some. Because if that capacitor is extremely leaky, it could be loading down the B+ voltage. Well, look at that. I replaced the plate bypass capacitor on the detector tube, and you can see the voltage jumped up considerably. 61 volts. Now, let's replace the coupling capacitor, and that should take care of all of the capacitors. Okay, that takes care of the grid coupling cap, and I misspoke a moment ago. I said this was a plate bypass capacitor for the detector tube. Well, actually, it's not. It's a string grid bypass capacitor. I knew 0.01 seemed to be a little bit too big for an RF plate bypass cap. Alright, now let's connect our DC voltmeter to the control grid of the audio output tube and see if it looks more impressive than the 16 volts or whatever it was we were getting earlier.
Because when the Crimson Tide are driving,
well, that looks more impressive. It also sounds more impressive. In fact, this thing's got so much gain now that when I turn the volume all the way up,
another reason why Ford is America's best-selling brand.
it overdrives the thing, and that's on a strong station, by the way. And remember, I said the volume control in this set is in the antenna circuit. It's not in the audio circuit, so...
Just in time for the holidays and the new year, the official Alabama Crimson Tide wall calendar.
Yeah, that's not bad.
It's the...
Okay, the next order of business is replace some of this ratty wiring. I think this goes to the dial lamp socket, and this either goes to the filter choke or the audio output transformer. I haven't traced it yet, but it definitely needs to be dealt with. Okay, well, the original bulbs were good. It's just they had gotten loose in the sockets, and by the way, the bulbs are a real pain in the butt to change in this set. You can't dismount the dial light sockets. You have to remove the whole dial assembly, and thank goodness the string was already broken. But once I screwed the bulbs back in, they were still very, very dim. fact, so dim they wouldn't even illuminate the dial scale. Couldn't find a number on the bulbs, but evidently someone had installed the wrong type at some point in time. Well, I installed a couple of type 46 bulbs, which I think is the standard 6.3 volt screw base bulb that is used in many radios from the 30s. And as you can see, it illuminates the dial at a reasonable amount of brightness. Okay, we have the Aetna radio working. Not bad for being a cheap radio. Only thing I need to do is restring the dial, and I'll do that once I obtain some dial cord and clean it up a little bit, but I can still tune the set from the knob on the front. Okay, it's 4:30 in the afternoon, and I believe this is WSM coming in. Of course, the radio is connected to the long wire antenna running outside of the shop, but that's still not bad performance for a cheap little TRF. Okay, we went with an 8 microfarad capacitor, which you see installed right there, and that gives us about the proper filament voltage that we need. Okay, reading across the filament string, we're reading about 60, almost 63 volts. With everything added up, with the tubes and the dial lamp, we have about 68 volts drop, so that's within range. So the capacitor is doing its job effectively. Now we don't have to have the exact on-the-nail voltage across the tube filaments. It can be a little lower, and the tubes will still work. Just as long as the filaments get the cathode hot enough to produce electrons, that's really all we need. Now we don't want to overvolt the tube filaments by much because that'll shorten their life. But this radio's been on a good while now, and this capacitor produces absolutely no heat. And that's what we were trying to get around, a heat-producing resistor. And we've effectively done that. And with the dial lights in circuit, even this can-ohm resistor doesn't get very hot. Now, if the dial lights were burned out or missing, this resistor would get very hot because it would be taking the full load. But with the dial lights in place, the dial lights are taking the majority of the load across this particular resistor, so that's why it doesn't run hot when the lamps are in circuit. Okay, I have it all back together except for restringing the dial. Let's do a little performance check here. Now keep in mind our volume control is in the antenna circuit. It's not in the audio chain, so I have the volume turned almost wide open.
Eagles were in Jaguar. That's right. The Eagles have never. It said, "It's your life." The answer seems so clear.
There's WSM booming in.
Beyond the clouds, it's just beyond. Right, and I've got this somewhere.
Got some interference there.
He's weak and his knees buckle. And it's like, where's the articulate guy that's going to say, we're going to stop robbing our kids?
I just noticed a text on the text line that our buddy
Those
Brad
two were
in East
local
Milton,
stations.
At the corner of Big Bend and the previous picture, the pigs had a very different nature.
He's the only one way to say Brad.
Attention, if you've had hip replacement surgery and suffered any complications, you need to listen to this important...
That's local, and that's as far as it goes. Now, I don't know what happened to 1390 WMER. They're the Southern Gospel Station. Their AM signal's been off the air for several weeks now. Their low-powered FM is still on, so I don't know whether they're having transmitter troubles and just can't afford to get it fixed, or whether they've decided to drop the AM and just go with FM. The one thing to keep in mind about these TRF sets is they're not very selective, as in if you've got two stronger stations in close proximity to each other, then they're pretty much going to run all over each other, like right here. Show you what I'm talking about.
At work. And so if you're listening to us at work, we always like to give you a shout out. We haven't done it in a while. But if you were listening, President Court in Texas, let us know you're listening to us at work.
10-10.
Republicans have.
That's 9-10.
17% interest rates, you could see them here. You will. If they don't do something, Sean,
let's see here.
Decide to leave, where are you going to go?
And with the gain turned up, you can really tell it, where they just run on top of each other.
If it ever came
But okay, there you go, the Aetna little cheap TRF radio from the mid-1930s.
Conservatives. You know, for John Boehner to go to
we were successful in replacing the original cold-ohm heat-producing resistor with an 8 microfarad AC motor capacitor, and it's working just fine. And there you go. Thanks for watching, and we'll do something again later.